Good evening, everybody, again for the second show this evening, and I am doing it an hour earlier tonight. I was hoping to do it at 9 p.m. BST, but 8 p.m. BST is just fine. It gives me a bit of an early night tonight, to be fair. Right, so this is Roundtable 16, Earth Not Spinning. So last week, if you remember, we had Bob the Science Guy on, and he did a presentation saying the Earth rotated. Tonight we are joined by Mr22brian22, and he is going to be doing a rebuttal to that presentation. Are you there?
I'm here, Andy, yes.
Hi, nice to see you back again. Now then, just to clarify a couple of things. Last week you were on, you did the solar analemma, and yes. I actually really enjoyed that presentation. I thought you put a lot of work into it, and it's one of the reasons when you emailed me, I was quite happy to oblige you in doing this presentation. Now, I know that you've put a lot of work again into this, so it's going to be quite an in-depth, long rebuttal to Bob the Science Guy. But the main thing I wanted to address was Quantum Eraser, because Quantum Eraser wanted a standing, within 10 minutes or so he could rebut anybody's presentation, and he wanted to do more than one show every 3 or 4 weeks. I'd said to him I was quite happy to just keep it monthly for one presentation per person. However, when I actually asked him to hinted that I wanted him to do a rebuttal to Right the Hand, he never did, so Brenda took that spot. So I was quite willing to allow him to break the mould on that and be the first one to have more than one presentation within the set time frame. But he didn't take me up on the offer, so the offer was held out. He didn't take it up. It's fine, it's not a problem. But he has his own platform, so essentially Nathan Oakley 1980s Flat Earth Debates is his platform. So he can obviously do his presentations on there basically at will. Unfortunately, you have a rather small channel, so
I don't have that bad.
But I actually enjoy what you do. I can see that you've got a lot of passion for this. I think you're quite knowledgeable, and I'm looking forward to seeing what you've got to do tonight. So is there anything you want to say to the audience?
First of all, I appreciate your compliments. I do try and do as you do yourself when you were doing your videos, making sure that you got all the observations. I kind of probably go a bit too long-winded maybe in sometimes, but it's like I want to get the message across. What I will say about this presentation is I was doing it when I was very tired, so I was a bit forgetful. So there was points in there I'm a bit scrappy, but the points that are in the presentation there's nothing wrong with them. They are still the points.
Okay.
Other than that, I don't really have much to say other than I appreciate your compliments.
Yeah, it's no problem. So just preempting what's likely to happen over the next probably day or two is I'm probably going to get another message on Skype from John telling me to stick a shotgun in my mouth and blow my brains out. It's how he communicates. He is rather abrupt with some of the things he comes out with. So without further ado, though, and not meaning to stand on anybody's toes here, I am going to present you for
what I would say about him is that what I notice about him, he is very abrupt, but he's ex-military, so I'd say that's just the way he always speaks, so it doesn't come across as bad. I don't get bad intent, if you understand what I mean.
Yeah,
but he is very abrupt. I hear him.
Yeah, I mean, me and Quantum Eraser have our differences. It's quite well known. But there's no animosity there from my side, at least. And as I say, the only reason, like I say, is that I brought you in for the second show within the 4-week timescale, is essentially because I enjoyed your presentation, and you were quite willing to step up and take on perhaps one of the most well-known globe Earth proponents, I would say. or at least in the top 5, I would have thought. So you know,
Probably.
you're taking on somebody here that's got some big boots, big shoes, and I'm interested to see what you can do with it. So I haven't actually seen the presentation, so
Yeah, I sent it later.
it's last minute. So I am completely trusting you that you haven't porn bombed me.
No,
But
no, that won't be happening.
right. Well, without further ado, I think
Yeah,
because you're on your telephone, aren't you? So I'll
yeah,
hang up the call with you now, and then
yeah.
basically we'll just crack straight into this. Okay.
On the ball. Okay, I'll talk to you a little bit later then.
All right. Yeah. See you in
Okay,
a bit.
take it easy. Bye, bye, bye.
Right, guys. Let's get this show on the road.
Hello, welcome to this presentation. It will be a rebuttal presentation to Bob the Science Guy's presentation on the Flat Earth channel, where it was about the spin of the Earth, or the supposed spin of the Earth. This will be a rebuttal to what he presented. Okay, I'm going to try to keep this as short as possible, but it will be long enough, as there's a lot of points I have to go through. So I'm going to try to start with Bob's first point and move through them. Okay. Bob's first point was about the where is he? There we go. That's what we want. So now involved this photo and another one I'm going to open up now. In a moment. Not that again. Now. So this was, I think, the first photo that Bob showed. And this photo is a photo of the sun lighting up the underneath of clouds. Now, this is not unusual to see the sun lighting up the underneath of clouds, as this is often seen as the sun is setting. This is the sun setting here. There is two answers for this effect on flat Earth. One is the low sun in our sky in December/January, just past solstice. And two, that this is actually the sun mirage and not the actual sun. As there is scientific study on the sun mirage, where the sun does mirage, and I'll show you some photos showing it, mirage, especially at the bottom, but it can leave a mirage as it leaves the atmosphere. So what happens is that due to the mirage and the sun, it tends to leave a light behind that's literally low in the sky but lights up the clouds underneath. Okay, I'm just going to go into here and I can see the things. There you go. Now, now, there is a sun mirage. Same thing, lighting up the whole sky, giving a red view or red hue to everything. It's actually miraging all the way up, as you can see. That is not the full sun. Okay, and even that might not even be the sun itself might be after moving from that point at this present time. Here is another sun mirage showing the sky all red. All the underneath of the clouds are red, but this is not the sun. This part definitely is not the sun. This might be some of the sun. This is not the sun. This is the mirage of the sun. This here is when it's starting to mirage, and as you can see, the whole sky is red as usual, and the clouds are red. This is not unusual. This happens all over the place, everywhere in the world, especially in warmer climates. You'll see a lot of them, maybe in Asia, off of Thailand, and maybe places like that, where are very tropical, or South America, them kind of places. So, 1 second now, just to see. I thought I had another one here. Was pretty good. Maybe I didn't. I have a lot of them there, so There's another, sorry. It's another mirage. So as you can see, that's literally miraging. There's not two suns there, that's a mirage. So the sun is literally a mirage, and look how red everything looks when it's miraging. All the underneath the clouds are all red, although they're a bit dark because the clouds themselves are dark, but if they were white, they would all be red. That's all. That's the only reason they're not all red. Oh yeah, this one. That is mirage, left behind by the sun. That's not the sun, that's mirage. It's left there by the sun. So the sun nearly leaves a mirage behind. Now, it can happen where the sun is just miraging into the water. So this is another thing about the sun going behind the horizon, that doesn't sinks into the horizon. Often the time it's the mirage that's sinking into the horizon and not the sun itself. You have to remember the horizon is only 3 miles away. So even on a globe, the sun could not be just sinking into 3 miles away of water, behind water 3 miles away. And even at that, you can be out 3 miles in the water and watch it sink behind 3 miles again if you believe it's sinking behind water. But often the time it's not. What's actually happening is it's leaving a mirage, especially on a warm evening. It's leaving a mirage behind itself. And it leaves a red hue all over. So I'll just come back to Bob's photograph a sec. So this is what the one Bob presented. And as you can see, it looks very like the other photographs I've shown. So I actually do think that this is actually itself is actually a sun mirage. And late in the evening, as you can see, it's so like the other photographs. And these clouds look the same, they have dark in them. They look the same as the clouds on some of the other photographs I showed. At the time of year in December, January, you will see a very low sun in the sky because at that point of the year it's at its lowest in the sky. So you will see a very low sun in the sky from anywhere in the world that you can see the sun, which is everywhere at that point, except for the Arctic. Okay, so I feel that photograph is just show this one more, just this one here. This is a double sun. Sorry, I'll make it a bit bigger. This is a double sun. So one of them is, there's either two suns or one of them is a real sun and the other one is not. So as you can see, and there's other photographs out there about the double suns, you can see that it's like the apparent sun where you think the sun is as opposed to where the sun really is. It's like, which one is the real sun? You see what I mean? Which one is the real sun? Now I'm going to go on to Bob's other photo. Which is this one. I just used this other side to write some stuff. This is a shadow of Mount Rainier early in the morning in the winter. Mount Rainier casts a shadow on the clouds during sunrise from the end of October to the end of February, early March, for two reasons. One, this is due to the sun's low and far position in the sky during this time of year. During the southern late spring and summertime, for reference, see the solar analemma. Two, Mount Rainier's massive size, as it stands at a height of 14,410 feet high, towering over everything in the state of Washington, USA. So, at this time of year, which is winter time in the north, and this is the state of Washington, which is probably, I think it's the most northerly state in the US, or one of the most, excuse me. And this is the highest mountain in the state of Washington. So basically what's happening is you have a very low and very far sun. It's at its furthest distance from the north during this time of year, and I'll prove that now in a sec. And it's at its lowest in the sky. Okay, I just want to go to, there's more sun. I just see, do I have, yeah. Now, this is the, just make it bigger, this is the analemma that I showed in my last presentation. This is the highest point in the sky. That would be in the northern summer in the end of June, start of July. That is its highest point in the sky. This is when the sun is at its highest and it's closest to the north. It's going over the Tropic of Cancer at that point. Around here is when it's going over the equator, and down here is when it's at its lowest point in the sky. in the southern summer and the northern winter, southern summer, and is going over the Tropic of Capricorn. This is at its lowest point and furthest point in the sky, down here. And it's at these points here, these three suns here, it's at these points in the sky that the effect is seen here on Mount Rainier, where it casts a shadow on the clouds, underneath of the clouds. Because the sun is so far away that it's hitting the opposite face of Mount Rainier, and it's causing a shadow from Mount Rainier up onto the clouds. That's what's happening. And it's nothing to do with the sun going behind the the sun going behind the curve of the earth or anything like that. I'm just going to show, where is it? I'm going to go back to this one. It's not about that. Just going to make this bigger. Now, this is, I know the quality, the resolution is not brilliant on it, but it'll have to do. This is the sun, path of the sun during the analemma on the flat earth. As you can see, in December, it's at its widest point and lowest point in the sky. So obviously, this is not the scale. This is not obviously the scale, but it's at its widest and lowest point in the sky. So if it's going over this line here during that time of year, and up here in Northern America is Northern USA is the state of Washington, then you can understand that early in the morning when it's coming in, it'll be coming from this side. I'm not sure which side it's coming from. I know the globe spins east or west, but for the sun, it's coming. Yeah, it's rising in the east. What am I saying? It rises in the east, so it'll be coming in this way, rising in the east. So you're going to see sunlight in a straight line up here to Washington, and it's going to hit the back of Mount Rainier, and it's going to be casting a shadow until the sun rises in the sky. Because in this photograph, the sun is not risen; it's only starting to rise. So that's basically what it is. It's only starting to come in. Night is starting to leave. This is the dawn. This is absolutely just dawn. And you can see here, it's dawn. Because if it was daytime, you'd have light coming across on the roofs here. Some of this would be melted. You could see the melted area. But as you can see, it's after being nighttime, because you can see the frost on all the tiles and all the roofs. So this is early in the morning. So there is no big mystery behind this. I just want to go and get the... one second. Bob's, I thought I had in this one. 1 second now. Where did I put it? Matta losing the one I was looking for. Don't matter anyway. I'll find it. Find it now. Okay, I found it. This was Bob's. Diagram. Now I put in the sun here and the writing and the sun rays here. Bob asserted that an observer, to see the sun on the bottom of clouds, would have to be looking up at the bottom of the clouds while the sun is coming in to hit the clouds. This is the line Bob drew, the blue line. The red line is the observer's line of view, and the blue line is the sun hitting the bottom of the clouds. Now, for that to happen, the observer would have to be in darkness, as this sun would have to be over here somewhere to hit the bottom of the clouds that way. It would have to be outside the observer's view. Bob's diagram shows how this effect should work on a globe. So this diagram is one of Bob's proofs, this diagram. So that's basically what I'm saying, is I'm being sarcastic about it, is that Bob's proofs is this diagram, basically, what he showed here, which is these two clouds, this red arrow and this blue arrow, and sunset, day and night. For this to happen, for this to be working on a globe, there would be no way that the sun would be able to, I don't think this would work at a long distance, because there'd be no way the sun would be able to hit the bottom of the clouds. So this, to me, the fact the sun is hitting the bottom of the clouds, to me, is a flat-out proof and not a globe proof. I could be wrong, but would this not be difficult on a globe? Considering the fact that there is a curve to contend with, would the sun not need to go below the horizon for this effect to take place? Considering that the sun shines on the bottom of clouds, like in Bob's diagram, a question mark. As I said, I could be wrong. I think that for the sun to hit the bottom of a cloud on a globe, it would have to go basically low behind the horizon. Because if you can imagine, let's say you're the observer, these are clouds. How much higher than you are clouds? Like if you went up higher, if something was going behind a curve and you got up higher, you will be able to look down at it going further. It might go out to your vision or your view from ground, but when you go up higher, you will be able to see it. So for this to work, the sun has to be on a globe. For someone who's on the ground, this would have to mean that the sun has to be below the horizon, at least for that person who's observing it. For it to be hitting the clouds, which is way higher, a couple of clouds. I don't know how high up they are, but clouds are pretty high up. They're a lot higher than the observer on the ground. So you're talking maybe a couple of hundred, couple of thousand feet sometimes. I don't know how high up clouds go, but they go pretty high. So consequently, even if the person went up 100 feet, they shouldn't be able to see the sun that's sitting on the bottom of the clouds. They should for the sun to be hitting the bottom of the clouds it would have to be at this kind of angle, as Bob shows himself. And there's no way for that person to be able to see the sun when it's doing that. So there'd be a red cloud for no reason. They'd just be red clouds. They call them sun clouds, but there wouldn't be any sun to be seen. It would be dark, but the clouds would be red. That'd be basically it. That would basically what would happen. So to me, as far as I'd be concerned, this is just not possible on a globe. But on the flat Earth, it's absolutely possible, as this is where the sun will be. So over here. And the person will be here. The sun will be coming straight across. It'll be moving around here, around this Tropic of Capricorn. It will be low in the sky, and it will be shining on the back of Mount Rainier, which is a massive mountain. And yes, it will cause a shadow up on the bottom of the clouds. So to me, there is no way for that to work successfully on the globe, in my opinion. And where is it gone? And there'd be no way for this to work successfully on the globe and be able to see the sun in any way, because that's obviously the sun coming up there. And I did get some other photographs, 1 second now, of this. Photos. No. Where are they on? I must have them in. It don't matter. I'll go back to, well, I think I know where they are. Sorry about this. I just have so many photographs to show. Right, so the photographs. Back to this. Now, yeah, there we go. Other photographs of Mount Rainier. Right, so there's there's a photograph of Mount Rainier with the sun doing that again. Okay. So the sun is definitely above the horizon here. It's not below the horizon, it's definitely above the horizon. This must be either very early in the morning. It must be very early in the morning, because the sun will be setting out over this way, so it has to be very early in the morning. You see, there's another one. There's another one of the sun up over the horizon. As you can see, it's up over the horizon. It's back here. It wouldn't be able to give that kind of for a shadow to happen. The sun has to actually be hitting the thing. So for this shadow to happen, the sun has to be hitting the other side of Mount Rainier there. So make it slightly bigger so people can see it. For this shadow to happen, the sun has to be on the back of Mount Rainier. So there's no other way for that shadow to happen unless it's at the back of Mount Rainier. The sun has to be hitting the back of Mount Rainier to cast that shadow, because there's no way for that shadow to be cast without the sun hitting the other side of Mount Rainier. That's the only thing that will give that shadow. So, in my opinion, Bob's there's another. Sorry, this one. There was small for some reason. It should be big. This one, there's another one. The sun is obviously up at that point over the horizon, and it's definitely hitting the back of Mount Rainier, because otherwise there wouldn't be a shadow. So you can't have a shadow on the clouds if there's no sun hitting the back of Mount Rainier. And as was shown in Bob's diagram here, the sun would have to be out of sight and view of the observer in a straight line for that to happen on a globe. And it's true, it would have to be like that. The sun would have to have gone down below the line of the observer's sight. So the observer is looking up at a cloud that's red in the dark, basically, or late twilight, but you would not see any sunlight. You would not see this. And I know that it happens in the morning, so either way, they are going to see red clouds in the morning before they're going to see the sun, if that's the case. So they're going to see a load of red clouds, and then they're going to see the sun, as opposed to the sun coming up and the clouds going red at the same time. They're just going to see red clouds in the dark, and then a while later the sun will come up over the horizon for the person on the globe. So to me, this is just not workable. It just couldn't work. You'd have to see red clouds first, and then see, or red clouds first, and then see the sun come up over the horizon. As opposed to in this photograph where the sun has to hit the back of Mount Rainier to create that shadow. And as I showed earlier about this photograph, that it's actually sun mirage, and this is actually more late in the evening, not early in the morning. So the Mount Rainier photograph is early in the morning, and this is more late in the evening. This is when this happens, late in the evening, when the sun is setting. So one is from when the sun is rising, one is from the sun is setting. So Bob gave this one for the sun rising, and he gave not that one. This one for when the sun is rising, and this one for when the sun is setting. So this is sun mirage as far as I'm concerned. It doesn't matter, it will work the same way anyway. As long as the sun is far enough and low enough in the sky, the same thing will happen. But this is sun mirage as I've shown and proven in the past few minutes. So that, to me, that first photograph is sun mirage. I don't even have to go down the road of the analemma or the low sun in the sky. I won't have to do that. And for here, the sun has to hit the back of the mountain to create this shadow. So the sun has to be up over the horizon. So there's no way that there is no way that can work on the globe. As for that to happen, the sun has to be up over the horizon to hit the back of the mountain. So if it's going to be up over the horizon here, there's no way you're not going to see it on the globe. For it to be up over the horizon, there's no way you're not going to see it if you're an observer on the ground. You're definitely going to see it as well as the mountain. But on a flat Earth, you won't, because the sun is not. The sun on the flat Earth is smaller, and in that time of year, which is winter, it's at its furthest point from you. So it's far from you. It's low in the sky, and it's a lot smaller than the sun that they believe is the sun in the globe Earth model. So I just don't see any argument here, to be honest with you. I don't see. Tell the truth, if Bob had watched my presentation that was on 2 hours after his one, then this would have, both his arguments would have been debunked there and then. But because I know, I'm pretty sure, I can't say I know, but I'm pretty sure Bob did not watch that presentation, and he just didn't pay any attention to it. And if he had watched it, it would have been, it would have proved with the analemma and with the EQ mount point I made that the Earth is not spinning, and it's not round. It's not a globe. But this is what Bob is asserting as what's happening. Yet it's against reality, as the redness on the clouds at the bottom in the evening time could only happen in Bob's world if the sun was going behind the horizon altogether. And in this, where are we? Sorry, the other one. In the Mount Rainier photo, the sun has to be in a straight line hitting the back of the clouds, or hitting the back of Mount Rainier to cause that shadow. And in this time of year, it would be, if you go by the analemma of the sun on the flat Earth. I'll just go back a bit. I'm not losing them all. What was I going to do? There we go. The analemma of the sun on the flat Earth. The sun is going to be out here, somewhere out around here. It's going to be starting to shine early in the morning in here into North America, and it's going to hit the mountain that's at its lowest and furthest away in the sky at that time of year. Now, Bob might watch this and might pay kind of no attention to it because he didn't watch my original presentation. But he should watch that presentation because it's very important, concerning the analemia. See, the analemia works so much better on the flat out than it does on the globe. And for me, it absolutely proves there to be flat and proves the globe to be a farce. Okay, let's go on to the next point as time is moving on. Okay, the next section is going to be about the sky, as that was Bob's, that's where Bob went to after that. He started talking about the sky and the star trails. So first I'm going to open up this. I'm just going to make that bigger. Okay. In this photo, Bob showed someone else's diagram, which shows a pre-assumed flat Earth with an AE map projection. The developer calculates a possible distance to Polaris and then proceeds to make Polaris the angular size of the Sun, which Polaris is not. So my first point here is that this is two observers here and here. This is supposed to be, this is a calculation of to Polaris, let's just say, from two observers' angles, let's just say. This, they're both, latitude is 75 degrees north, 1,666 kilometers from the North Pole. Okay, so the latitude is 75 degrees north latitude and about 1,666 kilometers from the North Pole. So the person who made this, Josh Lays, it was the star. He said the star must thus be at a height of 6,220 kilometers. But see, the problem with this is Bob showed this in a video format. I'm not going to show the video format because I wanted to write in on this. This is like the size that the Sun would be seen on the flat Earth. Polaris is not that size. Polaris is a small thing in the sky. It's only maybe a centimeter or a couple of millimeters in a square in angular size. So for a start, that's not way too big to be Polaris. A more realistic, although not yet proven map of a flat Earth would show a very similar layout up to a point, as the AE map shows. But the continents would be more the size in comparison to each other that we see on the Gall-Peters projection. That's just a little something I wanted to put in, that the AE map does not show an actual proper size of continents. If you look at the Gall-Peters map, it shows a much more actual size of continents. If you look at how small Europe really is in comparison to somewhere like Australia and that, as opposed to what is shown on a lot of the other maps like the AE map. But the AE map is just used on by the UN, and it's just kind of like the go-to, easy to find map to show a visual of a flat Earth. So in conclusion, if Polaris was represented in its more true angular size and the flat Earth layout was more true to what is realistic in as far as continent size and placement, then this diagram would hold more weight. Basically, the point I'm making is that Polaris is not shown in its proper angular size here, and this is not the correct world map, flat Earth world map. But I understand they just went with whatever one was most readily available. But if you see Polaris, it is only a tiny, tiny dot in the sky. So it is not this huge, big orange ball like we see here, which is about the size of the Sun. Okay. So next is this one. So this is more stills from the video that Bob showed. Polaris is, at this point, Polaris, there's two observers, observer A and observer B. In this diagram, it shows a very good example of what perspective does at a distance, as it shows how Polaris is dropped in the sky for two observers who now stand on the equator. So this is what happens when people move away from Polaris and it drops in the sky. What happens is that due to perspective, if observer A and observer B are two opposite sides of the equator, Polaris will have dropped in the sky down to almost at ground level. This is not exactly right because it'll still be above, it'll still be a little bit up. Their actual angle of view will be actually up slightly at this point, because it's not till the observer goes 1.23 degrees past the equator before they start losing Polaris. So this is not correct exactly. And Polaris would be a much, much smaller, as I said, much, much smaller item than this yellow thing, which is probably about the size of the actual real Sun. So Polaris is dropped in the sky for our observers, but it can still be seen until 1.23 degrees past the equator. So if you stand with your back to a very high building and you could walk away in a straight line, I understand Polaris will be a lot higher than that. But the point I'm making is if you're walking away in a straight line, you walk 20 miles away or less, you're not going to see the top of that building. The Burj du Dubai is the tallest structure ever built. It's the tallest building that we ever know of. Let's just say. Now, you can walk away from the Burj du Dubai and walk across the desert, and eventually the Burj du Dubai will just become a dot on the horizon. That's just what happens. It's your angle of vision is what causes this. It's after a while your angle, it just becomes so small. Its angular size changes and becomes smaller and smaller and smaller with distance, and that's just what happens as you go away from something. Regardless of how high it is, eventually it'll drop towards the ground. That's just because you're moving a huge distance away from something. And even Polaris, people believe that Polaris is 323 light years away, which would mean, and I said this in the last presentation, if we wanted to travel to Polaris according to that belief of Polaris, we would have to go at 617 million miles an hour for 323 years straight without stopping, just to get to Polaris in the globe Earth model. So Polaris is not like 323 light years away. Actually, the man who made this, Josh Lays, when he said it was 6,222 kilometers away, that's probably a more realistic distance to Polaris, as opposed to 323 light years away. Even though he would see that as ridiculous, it's funny that he would see that as ridiculous, and Bob would see that as ridiculous when they don't see 323 light years away as ridiculous. They don't see that as ridiculous, yet they see something that's 6,220 kilometers away as ridiculous in height. So it's funny to me that they don't see 323 light years away as ridiculous. But that's basically what happens as you get away from Polaris. Polaris drops in the sky. Now, next one, this one. Now. So in this diagram it shows, although not accurately, Polaris is positioned in the sky for different observers at different latitudes north of the equator. And once again, Polaris is shown to have an angular size more likely to the sun, to the true size of the sun, just like in the other diagrams. Hence, these diagrams are not showing the honest reality they could show. If this is 20 degrees north latitude, the arrow is pointing here, right? The person who stands here will see Polaris 20 degrees above the horizon. This is the same for the globe or flat Earth. So there's the observer there, and they're 20 degrees. They're 20 degrees north of the equator, and this is 20. Although this is not exactly accurate, is 20 degrees above the horizon. It works exactly the same on the flat Earth as it does on the globe. So what people believe happens on the globe Earth, where they move 10 degrees north of the equator and Polaris rises 10 degrees in the sky, and 20 degrees north of the equator and Polaris rises 20 degrees in the sky, etc. That exact same thing happens on a flat Earth. It won't change because you can only see something when you move away from it, no matter how high it is up in the sky. You'll only see it for so long. Eventually it's going to drop down in your vision. That's what's going to happen. So that's what happens on the flat Earth. Now, people on the globe side find that hard to believe, but that is actually what is happening. And what I'm going to show soon will start to prove that. Now, Bob showed, let's get the correct photos. Bob's photographs. They're here somewhere. Second now, we'll go back. I just want to get the photographs Bob had. Okay, I'll get it there. Okay, these are the two photographs that Bob provided. I did have an amalgamation of these put together, and some things wrote and annotated into it, but I can't find it. That seems to have been deleted because I'm dealing with so many photographs and different images. So it won't matter anyway. I'll deal without it. So in this one, this is the north. This is the north pole. This would be the north sky pole. This would be Polaris. And as you can see, the stars are rotating in this way. It's like they're going up, okay, up and over. This will be Sigma Octantis here, and this will be the south sky pole. And it's like as if the stars here are raining down. So there's two different time-lapse photographs. Now, excuse me, Bob asserted himself during his presentation that in the north and south, the stars travel in two opposite directions. Now, Bob knows that's not true. That is not true. That the stars always travel in the same direction. They always move in the same direction. They don't move in two opposite directions. Because it's asserted that in the north, things are kind of moving anti-clockwise, and in the south, things are moving clockwise. If you're looking at it from above the Arctic or above or under, looking up at the Antarctic or looking down on the Arctic. And the assertion that stars are moving in two opposite directions in the sky between the two hemispheres is not true. It would be true on a globe, but it is not true in reality. And I'm going to prove that now. Now, let's see, just go into here, make it this bigger again so I can see what I'm looking for. Now, first things first. Anyone of it? What's the best one for it? That'll do it for a start. This is from the equator. I'll go back on that one. This one I'm for. No. This is from the equator. As you can see, right, we are seeing this here. This is a time lapse from the equator. I think this is Ecuador, or Argentina, I'm not sure. But Juan Carlos Casado, I think, is the man who takes a lot of these photographs. This is one of the poles. I think it could be the north. This is the center of the spiral, and then we're heading towards over here, if we could see it, would be the south. And this would be Sigma Octantis, as far as I know. I think that's south and that's north, because that looks more like it could be Polaris. And what you'll notice is that all the stars move in all the same direction. They do not change directions between the two. And the assertion that they change direction is only because of where you're standing. So if you were standing and looking this way, the stars would be appearing to fall down to your left, over your left shoulder, let's just say. If you turned right around and looked back that way towards the south, then the stars would appear to fall down on your right shoulder. So they're not moving in two different directions. They're all moving in the same direction. And Bob was not. Bob was, he wasn't honest about that, because he just said they move in two different directions in the two different hemispheres. So that means that they are, that means that we're on a globe, and that we're spinning. But that doesn't mean we're spinning. That didn't even mean the Earth was spinning. That could mean the sky was spinning. Anyway, it wouldn't be a proof for the Earth to spin anyway. But Bob was asserting it as one. But the thing about it is that it's only a case of what way you're looking. So if you're looking towards this, if you're standing up here looking towards the north, the stars would fall over your left shoulder. If you're looking towards the south, the stars would fall over your right shoulder. That would be if you want to see it that way. So they'd just be falling because of where you're standing and what direction you're facing. That dictates what ways the stars will look to go in the sky. So they don't go two opposite directions. So I'm just going to get rid of this one. So now on to the next part, important part. Where is it going to? I'm not able to find anything. Everything seems to be missing. Oh, there it is. So going by what we see, and I'll show some more in a minute. What we see from the equator, if this is the person standing at the equator, will see both Polaris and Sigma Octantis on the flat plane Earth. This is not possible on the globe model from these angles, and that is a fact. It says down here, star trails would be impossible. Really? Why do you think that? Question mark. If someone was standing here on the equator, and this is Sigma Octantis and that is Polaris, Is that not exactly like what we were looking at here a minute ago? Is that not what we are seeing? If we had a bigger view of this, we would be able to see Sigma Octantis. And I will show you better views in a while. But this is what we would see. If we could see it, that's what we would see. So this actually proves flat Earth. This here proves flat Earth, and all the other views like it, because we should not be able to see that amount of stars and all the way to both Sigma Octantis and Polaris from the equator. We should not be able to see that if we're on a globe. That should be an impossibility. We go into this one, make it bigger, and I'm going to show you another in a minute, and then I'm going to show you some real life stars. So this is Polaris here, here, Sigma Octantis here, Polaris up here, Sigma Octantis here. So if you can imagine someone on the on the equator here, right, and someone on the equator here, right. This is for the person on the flat Earth, right. On the flat Earth, a person can stand at the equator and look to the left and to the right, slightly over the horizon, and see Polaris and Sigma Octantis. Okay, this is possible from the right vantage point on the equator for that to happen. With all the conditions correct, that can happen. And I'll show you in a few minutes. Now, whereas over here for the person on the globe, whereas on the globe model, seeing Polaris and Sigma Octantis to your left and right, slightly over the equator, is not possible, as a person would have to look down at an angle to see either, and would not be able to see both Polaris and Sigma Octantis in their peripheral vision, which is contrary to what we actually see from the equator. Right? It says here, so simple, not at those angles. It's not. You would have to look down to see Polaris and Sigma Octantis. You would not be able to see both Polaris and Sigma Octantis at the same time from the equator. And the only thing that seems to get into people's way from viewing them from the equator is not just the clarity of the night sky. It's all the topography of the Earth, all the land, and all the rest of it. That's what gets in people's way. So that's the only thing that gets in people's way. Because this here, well, if you imagine an observer here, and this is the flat Earth, let's say imagine the flat Earth, the person looking here at Polaris and looking at Sigma Octantis, this is much more the angles we actually really see. We don't look back, we don't like stand like this person here and start having to look back down to see Polaris or look back down to see Sigma Octantis. We don't have to do that. So if we were on a globe, we would have to look down and back. We would not be able to see. We wouldn't be able to see. I just go to a different photograph because I showed that one. Let's find the one I'm looking for. There's a few of them. There's one from Tuscany in Italy. Now, this one is from Tuscany. As you can see, if we could see more of the photograph, there was only so much allowed from a photographer. He's probably selling his stuff or whatever. If we could see more of the photograph, and this is from Italy, we'd be able to see this is basically past the center line here we're looking at, and it's going further. And this is going into the first vortex. This one will probably be up towards. It's going to be towards Polaris. So there's Tuscany, Italy. Let's see, where is this? This is this one. I'll show this one. This is from the equator as well. As you can see, we're seeing if we just had a bigger view, a bigger photograph, we'd be able to see a lot more of both of those. But what I'm going to show you in a while is something that was never done before. That's only been done recently in the past year or two, and it shows the whole sky. So you can see we can see a huge amount of the sky here. The only thing that's stopping us from seeing is our angle of view due to topography. Not that's the only thing that's stopping us from being able to see what we want to see. Back this way a bit. This is interesting. I'll show you this maybe in a small way. This guy was trying to do map the. This guy was trying to disprove flat Earth by mapping the sky, and he was showing the equator, and there was nothing in the way, and the south, Sigma Octantis, and the pole star. And basically, what he was showing, although it's not exactly perfect, basically what he's showing is what we would actually truly see from the equator. If you look this way, although they'd be more bended around, they wouldn't be exactly here. They'd be more this way and this way. This is basically what we would see. This is basically what we do see. So I'm going to find, there was a photograph from NASA here. This is, one second now. This is from the Joshua Tree, if I'm right, in the US. This is the Joshua Tree in the US, showing a huge amount of the sky, and that's up north in the US. We're not even down at the equator yet, and we can see where the lines here of the stars start to straighten out, and back here they're going to start to turn into the vortex again. 1 second, because that's what we have in our sky is 2 vortexes. So I'm just going to show you this one. This is from NASA. This is a photograph NASA took. And you can see how much of the sky we see. We're not looking down over anything. If we didn't have the mountains in the way, we would basically able to see so much more. We just have things in the way. NASA's own photo of the way too much of the way too much of the sky. Once again, we can see the start of the vortexes, and all the stars move in the same direction. All the stars moving in the same direction, and we can see the start of the vortexes here and here for Sigma Octantis and for Polaris. We can see so much here that we shouldn't be able to see on a globe. On a globe, this should go down lower, and the same with the other side should go down lower. We should not be able to see that so clearly and so easily. Where is it? There was a couple of photos here I wanted to show, a couple of really good ones. I'm after going past them so many times. So I'm going to show this one. Now, this one is this image, although taken with a wide-angle lens, as far as I can tell, is taken from the equator. And if it was not for land obstruction, we would see both sky poles. So that means that the whole sky was in the person's field of view from this position. And what is blatantly obvious in this photo is that all the stars are moving in the same direction, not 2 different directions as my opponent asserted. So this is a compressed image. It's at the compressing in the center. It would be a bit wider than that. As you can see, this is not a natural looking, although it is probably in the desert or whatever from the equator. This is a compressed kind of image. It compresses it in. So it would be a bit wider than that. But there is no way that somebody in the field could ever see all this in their field of view with a camera and it be on a globe. It just couldn't be possible. It's just not possible to see. Okay, on the globe, it's not possible. Let me see. Where's it gone? Okay, this is from Argentina. Sorry. I made them all bigger area, but they keep getting smaller. In this image from Argentina, we see into the start of both vortexes at the angle of about 40 degrees for the closer one, which is up here, and 30 degrees for the further one, which is over there, which is not possible if we are on a globe. As the angles have to be downward for a globe, we would never see this. This view on a globe of 24,900 statute miles, we wouldn't see that on a globe. This is Argentina, and we are seeing way too much of the sky for that to be possible. Basically, we have 2 big vortexes in our sky, one over the center and one moving on the outside. And this is the proof of it. The night sky is the proof of it. And I bet you any money that NASA have unbelievable photography of it, and they're not showing it to us. No. This is just from someone's back garden, somewhere near the equator. Another impossible view on a globe, as from a person's back garden, they are taking in the whole center and the start of the 2 vortexes and a little more of one, and a little more of one. So a little more of this one than that one. But they're taking in so much. This is a time lapse from someone's back garden. That's what that is. And they're taking in so much of the sky. There's no way on a globe we should be able to see that. This is an observatory one. No, I'm not going to show that one. Okay. This is a diagram I made. Okay, I'm going to show this actually. First of all, I'm going to show something else just to. I have so many things I have to show, and it's like doing 4 presentations, the amount of stuff I have to show. Oh yeah, I'm going to show this first. No, I'm back. No, where are we? Yes. Okay, so this is first photo. This is taken by Stefan Gussard in Ecuador. Right, I'm going to show you the video in a minute. This is looking north. This is the North Pole here, okay? This is the equator. Let's make it bigger. Sorry, they all have to get smaller settings or something. This is the equator, right? So he's standing on the equator. That first photograph was from the north, looking north from the equator in Ecuador, okay? Second photograph is from looking up above at the equator. Third photograph is looking at Sigma Octantis, right? This is Sigma Octantis, some kind of a shooting star or something there. That's Sigma Octantis down that way, Stefan Guissard. Okay, I'll show you what he did in a few minutes. I think it's a he. And this is a compacted photograph of the same thing. Okay, so this is north, south, and the center. Okay, now I'm going to show you a video that he made. It's the first one of its kind ever made. It's a virtual reality video using actual photographs, but it's a virtual reality kind of a. Where's the? There we go. Now, okay, back. Sorry, I'll go back in again. Sorry, I meant to read that there, T. The following animation is not just a time-lapse movie. It is not just a virtual reality image neither. It is both together, something like 900 virtual reality images put together, what I call a virtual reality night time-lapse movie. And apparently the first one ever created. This is from Stefan Guissard. These 900 images were taken during a whole night in Ecuador, near the equatorial line, at an altitude of 4,850 meters. If you just let the movie load and run, you will get to see it. So 900 images were taken during a whole night in Ecuador. So he took 900 images. If I clicked on this, it would show you the sky moving slow and all the rest of it, and the images happening, which I might do in a minute. But the first thing I'm going to do is I'm going to come down. Flash. These are the 3 photographs I just showed you before. Now I just have to enable flash. Now you're going to hear a bit of noise because I'm on a Mac. So flash and Mac don't work very well. Let's hope this loads pretty fast. Yeah. Sorry about this. As you can see, he's showing. I'm not the main big one. I didn't want it. It's small, not big. Sorry, just give me a second. I'll fix this. Now I think I have it working. If you just watch this, this is time lapse photographs. Hopefully, it's going to show. There we go. Yeah. There we go. Now it's working proper. Flash doesn't work well on Mac. So this is a time lapse of 900 images taken in Ecuador during the night and made into a virtual reality of the sky at a height of 4,850 meters. So 900 images created that from 4,850 meters. And 4,850 meters might seem like a lot, but it's as you can see, he's using a wide-angle lens as it's all curving all over the place. So don't worry about that. He has to do that to create the effect. It seems like it's very high, but it's nothing in comparison to how high you would have to go up to be able to see down to both poles. It's absolutely nothing for that. This is a wide-angle lens, so it's bent down. So this, you people can go and watch this themselves. Stefan Guillard, and it's a time lapse of the night sky. I would like to make it on full screen, but I'll try and make it bigger for a second. There we go. It's hard to get it to work on this small screen. So as you can see, it's showing there's the south, there is Sigma Octantis in the distance. It would be if we could see that far. And he's coming around. And you're literally above the height of a volcano, or near to a volcano height at this point. There's one somewhere in there, supposedly. He's coming around. It looks like just one big vortex. In some ways, it just looks like one big vortex, the sky at night. And coming around. And we will get to see more of this in time, when people are able to do this more. And there is coming into the north. As you can see, north. But there's no way you could see both. You wouldn't be able to see both and from the same two vantage point. To both of them from the same vantage point. You wouldn't be able to do that in reality. There's no way you could do that. As you can see, the lens he's using I think it's a wide angle lens. He's twisting and distorting things as he goes, but that's just the way it has to be. Okay. Sorry for the. Let's go forward a little bit. Let's see if this is. This is a slower. So this is when he was taking the 900 images there. That's the sky he got. So as you can see, that's the realistic. It's not all twisted up and messed up. It's not all curved. It was all curved like that in his last one. But that's because it is what it has to be, because of the way it has to be. For him to do what he did, to get the full range in, he had to use the lenses he used. So, just wanted to show you that. Now, this one up, sorry about this. So, the two diagrams I made earlier, that's what I want to go back to now. Now, when we look at the sky from the equator and we take time-lapse footage of the stars, we see very clearly that the observer has to only look left or right from a high elevation to see Polaris and Sigma Octantis. So it is blatantly obvious to anyone who is being honest with themselves that we cannot be on a globe, as from even a lower elevation at the equator, one can clearly see far too much of the sky and the poles. And this observation absolutely screams that we are on a flat plane. So these arrows, right? These arrows show an observer's direction of view to the poles. So the direction of view will be from an observer here on the equator, will be out straight out left and straight out right. These other two yellow arrows show an observer's angle of view to the poles. So he's not going to look, he or she is not going to look straight out left and straight out right. When they look out, they're going to have to look up slightly, as both Sigma Octantis and Polaris will be slightly above the horizon. Okay, now a question, this is be for some interaction with the people in the chat and people watching this. This is something I would like people to do right now. And if Bob is watching this, I would like him to do it. To Google, how far north can Sigma Octantis be seen? And see what answers you get. So how far north, Google now, not with DuckDuckGo or Yahoo or anyone, just use Google. How far north can Sigma Octantis be seen? Google that and put into the chat what results you got. This is interesting, as I found it very interesting. Okay, and also after you've Googled that, I want you to Google how far how far south can Polaris be seen. So start with how far north can Sigma Octantis be seen. Then ask how far south can Polaris be seen. This is interesting. I tried to find out this particular information over the course of a week or two, and no matter what question I asked, I couldn't get to find out what I wanted to find out about Sigma Octantis. Okay, put that into the chat, and I will answer on it after the video. Okay, on to the next diagram now, which is this one. Okay. So this arrow here points up to Polaris, right? This arrow points up to Polaris on the globe. 2 sigma octantis. This one points down 2 sigma octantis. Okay, this is the observer here on the equator. This is the real world angle of view to Polaris. This arrow here, the real world angle of view to Polaris. It's actually above the equator. Excuse me, above the equator. Right. This one here is the real world angle of view to sigma octantis from the equator. This is above the equator also. Sorry. So this one and this one are real world angles to of view to sigma octantis and Polaris, as I have proven already with the photographs from the equator. These ones here, these angles of view, right, that are going down this way and down this way, these are the needed angle of view on a globe is down, not out. And the same for this one, the needed angle of view if on a globe is down, not out. So there is no way that anyone standing at the equator would be able to see Polaris or sigma octantis both at the same time. Even seeing one of them would be, I think, would be very, very difficult on the equator in reality if you're on a globe. As to see, you would have to be able to look down at this angle all the way down here. And the same here, you have to look down all the way down here. And it's just not possible on the equator, especially considering you're only going to be a very small person. Even if you're up on a mountain, it won't matter. Your elevation is not enough. As I've proven earlier with my photographs, well, not my photographs, but the ones I got of the sky from the equator, we're able to see way too much even from someone's back garden for that to be for us to be on a globe. So I firmly believe this is an absolute globe killer. The fact that we can see so much of the sky from the equator, I think, is absolutely a globe killer. So what Bob used as an attack on flat Earth and a proof of the globe is actually a proof of flat Earth, not a proof of the globe. Okay, now we'll move on to the next part because it's moving on. Okay, now we're going to move on to the gyro compass. Okay, now this is the gyro compass, Sperry gyro compass manual. This is one of their older compasses. Now they use fiber optic gyroscopes. They don't use manual gyroscopes anymore. But I'm just going to show something here, something that I found. That's very interesting. Okay, let's go down a bit. Now, let's see. Here they talk about the gyro with its spinning axis set in the east-west position at the equator appears to turn about its horizontal axis once every 24 hours. So it basically, what they're saying is it will basically precess around in 24 hours. I think precess is the right word. Every 24 hours. So the Earth turns in the direction of the arrow or clockwise with an angular velocity of 1 revolution every 24 hours, carrying the gyro around with it. But the gyro, because of its inertia, maintains its original plane of rotation in regard to space, just as it did when its base was tilted, as shown in Figure 3. That's up above. But with respect to the Earth, however, the gyro rotates about its horizontal axis with an equal velocity, 1 rotation in 24 hours, but in the opposite direction to the rotation of the Earth. So one of Bob's proofs of a globe was that the gyro will precess 24 hours, around 24 hours, take 24 hours to precess around in a circle the opposite way to the spin of the Earth. After 3 hours, the end of the axle will be pointing will be pointing east, apparently is elevated at an angle of 45 degrees. After 6 hours, 90 degrees. After 12 hours, 180 degrees, and so on, until the end of 24 hours, it is back where it started. So basically what this, rather than read, because there's so much to read here, I'm not going through so much of it. Basically what they're saying is that the gyro moves will spin, precess the opposite way to the spin of the Earth. You see, where is the pattern for right? So what the thing about the gyro is this: what Bob did not say. He was saying Bob said that the gyro finds its own. It finds the north itself, and that's not true. It does not find the north itself. So I'll put that down there. Okay. Oh, sorry. Compass. I think it's this one. Okay. A true north-seeking gyroscope, the gyro spins at a very high velocity and its spin axis remains aligned with terrestrial meridians. The gyro has three axes: the spin axis, the torque axis, and the precession axis. Okay? So why does the gyro compass always supposedly seek true north? Why does it not seek the true south? Because when it is being started up, it is set to north. It does not just find it itself, as has been asserted. So gyro compasses do not find north. You have to set them to north. And often the time what is used is actually a magnetic compass is used for the gyro compass to find north. And then they set it at that, and it works from there. And it has to be checked periodically with a magnetic compass to make sure it's still pointing north. So it does not, as Bob asserted, it does not find true north itself. That does not happen. But this is the part that's really interesting. To make the gyro seek the north, a mercury tube is added. Its effect being applied about the horizontal axis. So there's a mercury tube added. There's a tube with mercury on it as basically as its horizontal axis. Okay, so what that means is the diagrams are misleading. Okay, some of these diagrams are very misleading, and the way they're worded is very misleading, because what I'm going to show you in a minute is going to turn people's heads, I reckon. The Earth's rotation rotates this way, and the gyro precesses that way. Well, there's a reason why it does that. I'm going to read just this part. A gyro with its spinning axis set horizontal at any point away from the equator maintains its plane of rotation in space and apparently moves about both its horizontal and vertical axis. Rather than going into everything about the gyro, I'm just going to show something. There's the mercury tube. Okay, now it's asserted in this manual. If I might find it in a while, where it's asserted that it's due to gravity and Earth's rotation that this is happening. Right, basically, this is the mercury tube. It starts to turn anti-clockwise. Okay, or clockwise. I mean, as Earth's supposed rotation is anti-clockwise. If you're looking at it from above the Arctic, then this will be turning clockwise. So the Earth's rotation is supposedly anti-clockwise. If you look, let's just say if you're looking down above the Arctic, and this is supposed to turn opposite from the rotation, it's supposed to turn clockwise. But the problem with that is the globe's rotation from under the Antarctic, if you're looking up, will be clockwise. So it's only turning supposedly against the Earth's rotation when it's in the north. When it's in the south, it's not. But that's not the important part. If you look here, they show the diagram. They show this how this starts to move around, right? The mercury tube, and turns. And as it does, this spinning axis starts to point upward. Okay, starts to point upward, and the mercury tube ends up being basically this part here was there, then it's here, then it's there, then it's there, and it's showing how it's doing that, and it's showing how the spinning axis ends up pointing upward. Now I'm going to go down here a sec. Now this is a diagram here. This diagram showing the movement of a mercury-controlled gyro wheel when set with its axle pointing east of north. So this here, okay, this little mercury tube, it's set with its axle slightly east of north. So once this is pointing towards north, the spinning axle is pointed towards north. That means this tube is set slightly east of north. So the reason for that, right? People think that the reason it ends up leaning back and spinning is due to gravity and the rotation of the Earth. This is what they're saying. It's about gravity and rotation of the Earth. It's not about any of those. And I believe I have figured out what it is. Okay, what's making it do it? And it's not the rotation of the Earth, and it's not gravity. Now, I just want to come down first and show you this. This is a more true, because this is a kind of a cutaway, basic version of what is actually going on inside the gyro. First, I'm going to explain the points, right? As shown in Figure 13, which is this one, the rotor is contained in a case number 1. So this casing is number 1. The case is supported on horizontal bearings in a vertical ring 2, okay, which is 2, so there's supported with this vertical ring here. The rotor case and the vertical ring are free to turn about the, I have to go back up here, it's the vertical suspension axis, which is 3, okay, where are we with 3, which is here, then at the bottom. Although the gyro compass as shown in figure 13 necessarily differs in its details of construction from the model gyros shown in some of the previous illustrations. So basically what they're saying is the real one that they would have been putting into gyro compasses is a lot more parts as this one here, a lot more parts than your basic one over here. It has the same angular freedom about its spinning horizontal and vertical axes and exhibits exactly the same characteristics. Okay, so figure 13 shows the addition of an outer frame, number 4, right? There's number 4, the outer frame, okay, called the Phantom. This is known as the Phantom. That outer frame is known as the Phantom, okay, which is driven by an electrical follow-up system so that it follows every movement of the gyro about the vertical axis. By supporting the mercury tube or ballistic, number 5, right, there's the mercury tubes, ballistic, right, in bearings in the phantom ring, we can obtain a controlling action about the vertical axis of the gyro so as to arrest its oscillations and cause it to align itself with the meridian. Okay, this is accomplished by connecting the mercury ballistic to the gyro case at a point 6. Okay, as you can see, this is center and this is off center, right? This is off center of that. If this is north, that's south, that's east, and that's west. This is connected slightly off center. Okay, off to the east of north, basically, if you think of it that way, as we spoke about earlier. Although it's not, you'll understand this in a few minutes. Slightly to the east of the vertical center line, right? Again, that's exactly what they say. Exactly what they're showing is exactly what they're saying. Slightly to the east of the vertical center line. With this arrangement, the major effect of the mercury still acts about the horizontal axis and causes the gyro to precess towards the meridian as before. But there is now an additional effect about the vertical axis which causes the gyro to then we'll have to go down, precess about the horizontal axis, right? And we're going into other stuff there about what the gyro is precessing, right? But I just want to read this. I just wanted to point out those few points about this older. This is one of the older gyro compasses. In order to obtain a more symmetrical construction, the mercury ballistic consists of 2 sets of containers and tubes instead of the single pair of containers shown in previous illustrations. So there's twice as many. So there's not just 2 containers and a tube, there's twice as many containers. Okay, it's not just one. There's more mercury being added into it in containers and tubes. Right, now I'm going to show why. Right, this was asserted. Where is it in the book? If I can find it, after trying to remember so many things that I can't remember where they. But where they wrote about the gravity in that. But they had it in about, sorry, I'm not going to waste time. They had it in here about gravity, about how gravity was responsible for gravity and the spin of the earth was responsible for why the gyroscope did what it did, right? Why this moved around clockwise as opposed to the anti-clockwise of the spin of the supposed earth, which only happens in the north, because in the south it happens clockwise. So it's not opposite. Does it go opposite in the south? No, it doesn't. It still goes the same way from what I can find out. So now I'm going to show something that a very short video. It's only going to be a minute or a couple of minutes. I'm going to move it on, right? This is rotation of liquid mercury generated by a magnetic field. Okay, play, have the sound off. So I'm just going to move it on a bit. You connect up a magnetic field, put in the mercury. That's what they're doing there. And then what they're going to do is add just a little bit of talc in here, right? Just so you can see the mercury moving, because otherwise you won't be able to see it so well. So you'll be able to see the mercury moving when it does. So electric current, liquid mercury inside a container, okay, and now they're going to add a magnet. So one side of the magnet will be positive, one side will be negative. So when they use the positive, it goes clockwise. Or when they use it with the red side up, which I think is the positive side up, or maybe it's the negative side that's been used because the green is down. But either way, when they use this side, it goes in a clockwise motion. Now they're going to turn the magnet around, and they're going to leave it still, and they're going to put it in so the green side is up, and watch it go anti-clockwise. So now it's moving anti-clockwise. Okay? Now, Mercury itself has a very low magnetic rate, or let's just say it's not very magnetic, let's just say, right? They set this Mercury tube, right, slightly east, right, of north, which means it's set slightly to the right. If it's pointing directly at north, it's slightly to the right. Basically, if you come over here, what you'll be dealing with, if you're on the ocean, basically what this is doing, once this needle here, once the front of the spinning axis is pointed towards north, right? Once they have it set to north, the Mercury, there's an electric current running through the gyro compass. That electric current interacts with the Mercury, causing the Mercury to move, wanting to move away. Because this is something I didn't say earlier. Mercury naturally, when it needs an electric current to start to move and become anyway magnetic. But it always wants to move away from magnets. It always wants to move away from something magnetic. So Mercury moves away from magnetics, right? Basically, okay. So what's going on here is the Mercury naturally wants to move away from what is north. This is true north, but the north pole would be, the magnetic north would be here, let's just say. If that's true north, that would be the magnetic north would be here. So it's always wanting to move away. So it starts to turn, and it turns right down, and the Mercury that was here ends up flowing into here. And then that turns away, and then that turns away, and then that turns away. And this causes the torque, which causes the precession, and whatever way they have it timed with whatever amount of electricity, it actually causes it to go take 24 hours to go around, to precess it around on its vertical axis. So the spinning axis has the horizontal axis moving around it in a clockwise motion, and then the vertical axis ends up, because of the spinning axis and the torque. If you look into basics of how gyroscopes work, if you have a spinning axis and a torque moving, and then the torque being created by the horizontal axis, if the horizontal axis is moving in a clockwise motion, then it will precess on the vertical axis in a clockwise motion. So it's not gravity, it's not the rotation of the Earth. It's three things: it's electric current, it's liquid mercury, and it's electric current, liquid mercury, and it's magnetism. And that's what it is. This is the older version of the gyro compass, and that's what caused it. And they assert several times that it's gravity, and that it's the rotation of the Earth. In this, within the first few pages, it's asserted. I'm only on page 12 here. That's the reason why the tube here, the horizontal axis, is doing what it's doing, and that's the reason why it goes opposite from the Earth. Why would it go opposite from the Earth? How does that make any sense? Why would it go opposite from the Earth anyway? I don't get that. I never understood. Why would it be going opposite from the Earth? If the Earth was spinning in an anti-clockwise motion, would the gyro not be drawn towards that motion? It doesn't make any sense that it goes against the rotation of the Earth anyway. It never made sense. Well, not that I believed in the rotation of the Earth, but I'm just saying it wouldn't make sense anyway. But it's a con job. It's mercury, liquid mercury, a magnetic field, right? Magnetic field, liquid mercury, and not magnetic field, an electrical current, liquid mercury, and the North's magnetic field. That's what it is. That's what's happening. So it's a con job. the gyro compass doesn't prove anything. It only proves that an electric current, liquid mercury, and a magnetic field will cause the gyro to do that. If there's mercury tubes, if there's a mercury tube inside that allows the mercury, that's not totally filled to the top, so allows the mercury to fill one side, and then this top here is pushed away. As that pushed down, this fills this side, and it keeps going like this. It keeps on wanting to pull away in this direction from because of the way it started. It started at an angle here. If you started at the other, if it was started and configured at the other side, it would probably go the other way. Because if I just come down here, this is set east of centre. So I reckon if it was set the other way, that it would go the other way. So there's a lot of stuff after being asserted about a gyro compass that I believe has been totally debunked, that it's all a con job, that the people who made it knew there was no rotation of the Earth and knew what they were saying. Even if they didn't know there was no rotation, they knew what they were saying is nonsense, that it was gravity and it was rotation. But these days they have fibre optic gyros in the compasses, in the gyro compasses. So they work with fibre optic gyros now. So I'm looking into that as well. But either way, it was asserted a long time ago that this was rotation of the Earth and gravity, and it's not. It's not any of them. It's liquid mercury, electrical current, and magnetic field from the North magnetic pole. That's what it is. But that, I believe, is actually the South magnetic pole. And when it was had the red side up, I don't know if it was the green side or the red side. I would like to know which was which, as far as which was positive and negative, or what way it was working with that magnet, because that will tell us. I'm going to go and try and find out. I'll even send a message to the guy. That will tell us what the North magnetic pole is. Is that a positive or a negative? Because that will tell us whatever one it is that made the mercury go in a clockwise motion is the same magnetic force that makes either a positive or negative that's making the mercury tube travel in a clockwise motion. So I'm going to find out that, and when I find out, I'll let people know. So now I'm after taking a long time on this presentation. There's 2 more sections, and I'll be as fast as possible with them because it is a very long presentation because there was a lot to cover. And I have to say that I'm being very unorganised tonight. So and it's very late at night, so I'm not doing a great job of it. So now, next thing is the laser gyro. For this, I'm not going to spend too much time on this because I didn't have a chance to learn about the ring laser gyro and the fibre optic gyro like I wanted to, because I spent a lot of time on the gyro compass. I had to spend a lot of time on the gyro compass and learning about that and other things to do with the sky. So this is, where are we on? This is the fibre optic gyro, okay? And this is the ring laser gyro. So, make them smaller, you can see both of them. If it'll do it for me. No, I don't want to open up that. It's opening up anyway. Okay. They both work off of interferometry, right? Both the fibre optic and the ring laser gyro. I have something I've only been learning about, so I'm going to speak about these from what people say about them from a logical point of view. It is asserted that both of these gyroscopes, that they measure a 15-degree drift, okay? And so it's asserted that what they're measuring is the rotation of the Earth. Bob, the science guy, asserted it, and he showed Bob Nodell's a clip from the Behind the Curve documentary. He showed Bob Nodell the clip where he was speaking about this drift. That was in a fibre optic gyro belonged to a member of FE Core. Now, the thing about that is there's some major problems with the 15-degree drift and what they are picking up. And I'm going to show you why. This is supposedly the analemma of the sun on the globe Earth, okay? This is what explains the analemma. So at aphelion here, the Earth is supposedly 152 million kilometers, 152,100,000 kilometers from the Sun. At perihelion, it's 147,300,000 kilometers from the Sun. So the thing about that is, what happens is, at aphelion time, when it's furthest from the Sun on the globe Earth model, the Earth is supposed to be slowed down at its slowest point. So it has the slowest rotation. That's what gives us the long days. That's what they say gives us the long days during our northern summer. Now, obviously I don't agree with this, and my presentation last week totally debunked this. But it doesn't matter, because this itself debunks what Bob the Science Guy is saying about the gyros. As the assertion is that the gyros are picking up a 15 degree per hour drift all the time. How can they be picking up a 15 degree an hour drift all the time when when the Earth is supposed to be speeding up and slowing down? So it's slowing down all here, then it's speeding up all here, then it's slowing down, then it's speeding up, then it's slowing down, then it's speeding up. So it's never ever at an equal time, an equal amount. It might be for a short length of time, but you could not be always getting the same reading of a 15 degree an hour drift. You would not be able to get that if it was the Earth that was moving, because this would show that is not possible. Okay, because the Earth in the globe Earth model keeps slowing down and speeding up and slowing down and speeding up. Right now, in the flat Earth model, it's not the Earth that's slowing down and speeding up, slowing down and speeding up. It's the Sun that's doing it. In our model, the Sun is slowest and highest and making it when it's going over the Tropic of Cancer, okay, in the northern summer. Then it starts to drop down as it goes through the equinoxes, or through the September equinox. And it starts to come down to its low past the equator and widening out. It's moving faster and it's widening out till it gets down to its lowest and widest point, where it's moving fastest around the Tropic of Capricorn. This is a fact. This is really happening. This is not something that I'm making up. This is really happening, and it happens all the time, every year, all the time. So the Sun is always slowing down and speeding up in our sky. It's asserted that it's the Earth that's doing it by the globe Earth side. It's asserted by Flat Earth that it's and I think I've totally proven that last week with my presentation, that it is the Sun that's doing it and not the Earth. Okay, but either way, it doesn't matter, because it cancels both of them out. It can't be the Sun or the Earth that's being measured in this 15 degree drift. So it has to be something else. Some people have asserted it was the ether. I can't assert that. It hasn't been proven. I can't assert that. I understand why people would assert that. To me, I think it's just picking up the sky. There's a 15 degree drift per hour in the sky, as whether you believe it's the Earth or the Sun that's slowing down and speeding up, it's only the Sun and the Earth that's affected. The sky is still moving at the same speed, as far as I know. So I think the only thing that the fibre optic and the ring laser gyros could be picking up, if they're picking up a 15 degree drift, it has to be the sky, because the Sun, either the Earth in the globe Earth model or the Sun in the flat Earth model, are both either slowing down and speeding up, slowing down and speeding up. So they're never holding a constant rate. So if you're always getting the exact same 15 degree drift, then it is not the Earth and it is not the Sun. So it has to be something else. The only other thing I can think of is the sky. So it can't be the Earth and it can't be the Sun. Regardless of what you believe, whether you believe in the globe or the flat Earth, it can't be either of them, because they are not moving at a constant same rate. They are changing. The Sun changes its position all the time in the sky, as is proven by the analemma of the Sun, and it's changing its speed, and it's changing its rotation, its width of its rotation. So its speed is changing, the width of its rotation, and its height in the sky is changing throughout the year. Okay, so this is the people who believe in the globe calculate that the Sun doing this means the Earth is moving, because the belief is that we're going around the Sun. So on the globe Earth model, the Sun can't be doing it because it's more or less stationary, or we're going around it. So it's asserted that it's the globe doing it, and it can't be the ground that's being picked up then by the 15-degree drift, because the ground being picked up by that would mean that it wouldn't be a 15-degree drift all the time, because it's constantly changing its speeds. It's always changing its speeds because the sun is always changing its place in the sky. The sun is always changing its speeds, and it's changing its width of circle. So regardless of whether you believe in globe Earth or flat Earth, it can't be the Earth and it can't be the sun. So it has to be something else. So I'm sorry, Bob the science guy, but these two are not picking up any movement of the Earth or the sun, because they can't be. If it's a constant 15-degree drift, it can't be, because that is not going to be a constant with whether in the globe Earth or the flat Earth model. Okay, we're on to our last section now, which is the EQ mount. Okay, so these are several arrows. This is supposed to be the axis of the globe. These are several arrows that are on the same, all on the same latitude, let's just say, right? Question: which arrow or line is pointing toward Polaris? Answer: this one. That black line there. It's 3/4 of a degree off of Polaris. The other red arrows are constantly moving, so they could not stay pointing at Polaris, as Polaris is stationary, and they are on a moving globe. The reason I'm putting in them those arrows is, if you polar aligned your EQ mount at this point here, on this first red arrow, and the Earth it's moving from east to west, right? It's moving anti-clockwise. So no matter where you put your EQ mount, no matter where you along this line alone, you polar align it, it will not stay polar aligned for literally only a couple of minutes at best, even only a couple of minutes, because it's eventually going to move. Because if you're on a globe, the point I'm making is, if you're on a globe, then the globe is moving, so the EQ mount will be moving. So there is no way for it to stay aligned. It's just not possible. Imagine that this red line is in line with the axis of the globe, right? This red line here, right? So it's pointing towards Polaris, okay? Right, pointing to true north and onwards to 3/4 of a degree of Polaris. Now imagine that you're in Central America on the central USA, on that particular longitude line, and you polar align your EQ mount telescope with this red line, and then the Earth spins? Question mark, right? So you can imagine this side of the globe here is the northern hemisphere, and this side is the southern hemisphere. So if a ship can move 10 degrees north or south in the northern hemisphere and change Polaris' position in the sky, then how could you ever keep an EQ mount polar aligned when you're constantly moving out of alignment by 785 miles per hour in Nebraska, for example? So, because that is the rotation speed in Nebraska, right? 785 miles per hour. It's on the 41st latitude, I think. At those speeds, how could you ever align it? Especially considering ever align it at all? Like, could you ever align it? Especially considering Polaris is very small angular size in the sky. Okay, so all these red arrows show the alignment of your EQ mount if the Earth was to spin? Question mark. Right. Let's say your EQ mount was in western Nebraska, USA. Then the rotation speed at that latitude is just over 785 miles an hour. So an hour after getting your EQ mount polar aligned, it would already be 785 miles away from your original alignment. How would it be possible to align it at all on a moving object? Question mark. How could you align it on a moving object? You couldn't. You would literally, especially at that 41 degrees north latitude, it would be 785 miles an hour rotation speed. So literally, the moment you have it aligned, it'll be going out of alignment. Polaris only ever moves its position in the sky if you move. If you stay stationary, then Polaris also stays stationary. So if you polar align an EQ mount and it stays polar aligned, then the ground it resides on is as stationary as Polaris is in the sky. So if you can polar align an EQ mount in the northern hemisphere or the southern hemisphere, and it doesn't move from that, once it's not moved or tampered with, if that would stay polar aligned, even for, if you put it out for 2 hours and come back and take it down, then if that didn't move its polar alignment in those 2 hours, then the Earth has to be absolutely 100% stationary. There is no way around that, as once the Earth would move, they will lose their polar alignment. Polaris only ever moves in the sky when you move on the land or sea. Other than that, it stays stationary. So if you polar align an EQ mount telescope and it keeps its alignment, as they do, then the ground that the EQ mount telescope is situated on has to be stationary. Otherwise, it would lose its alignment almost immediately. As if once polar aligned, you move the EQ mount a foot to its right or left, while holding the exact same elevation from the ground and keep its initial line. It will show to be out of alignment. So basically, if you polar align your EQ mount and you move it then 1 foot to the left or to the right, keeping the exact same elevation and keeping the exact same line. So not moving it back at an angle, keeping it exactly in the same line, 1 foot left or 1 foot right, it'll be out of alignment. Right, it will show to be out of alignment, as Polaris, regardless of your personal beliefs on its size and distance, has a very small angular size in the sky and does not move. So if Polaris does not move, and it does not, and your polar aligned EQ mount telescope is staying aligned, then that means that the very ground that your mount telescope resides on is stationary too, as you cannot polar align an EQ mount telescope on a moving object, and that's just reality. These arrows show the progress that can be expected from a North Polar alignment EQ telescope, as the globe Earth would turn on its axis, starting from the yellow arrow where the EQ mount has been aligned to the turquoise, on the yellow arrow, which is here. The EQ mount has been aligned to the turquoise, right? So it's starting at the yellow, then it'll be moving to the turquoise, okay? So the yellow arrow is pointing towards Polaris, but then the turquoise one is not, and then on to the green one, which is not either. So eventually what's going to happen is that you're basically, or if you did it the opposite way, it doesn't really matter which direction it would spin, because either way, you're going to lose it immediately. Right? You can clearly see that there is no possible way that the EQ mount can successfully stay aligned once moving or being moved. Now, basically, if you move an EQ mount in any way, shape or form, once it's being polar aligned, it loses its polar alignment. So it cannot stay polar aligned if the ground it's on is moving. So this is the Bob the Science Guy. The EQ mount having a polar alignment totally proves that the Earth is not moving. Because if you polar align an EQ mount, it stays polar aligned unless you move it or tamper with it, right? Unless wind knocks it over or a dog runs into it, right? It will stay polar aligned. As long as you can see a clear night sky, you will still see Polaris in the lens for the polar alignment. Okay, so this completely disproves any movement of the globe. So that is basically the end of the presentation. I know it was long and it was a bit very scrappy. I tried my best to keep it, to try and make it as flowing as possible, but unfortunately I ran into I lost photographs and stuff like that I should have had, that it's things I'd done and diagrams I'd made weren't there. I don't know where they went there, but I still went on with it anyway. So, to Bob the Science Guy, the gyro compass does not prove the rotation of the Earth, as I have proven with the Mercury that it was Mercury that was causing it to move. It was causing it to move and causing the precession. So whatever they're doing with gyro compass, the ring laser and fiber optic gyros, I don't know, but I've proven that I think I have significantly proven that they are, I don't think that's the right word, that they are not picking up any movement of the Earth according to the analemma of the Sun. So if you look at the analemma of the sun and what the Earth is supposed to do in the globe model, I look at it on the flat Earth model of what the sun is supposed to do, then there is no way it can be picking up any of those, right, in its 15 degree an hour drift. It has to be the sky or something else. It's not picking up those. When it came to the night sky, I proved that it is proof of a flat Earth. If you can see that much of the night sky from the equator, and that's without having to look down, you're looking up and off at up and out at an angle. You're not looking down to try and see a pole, and you could only do that at one side. You would not be able to do it at both sides. You'd have to go and look at one side, then come back and look down the other side at the other side. That's the only way you would be able to do it somehow. So people can test that for themselves, as with the way things are going now with cameras and stuff like that. I'm sure we'll have a lot more footage of the sky. But the sky itself completely proves the flat Earth. The sky that the globe Earth are talking for a long time about being a big globe Earth proof, it's not. It's a flat Earth proof. You have to look down at an angle to see the Polaris or Sigma Octantis, and you don't have to do that in reality. In reality, they're above you and off to the left and off to the right from the equator. And they don't spin in different directions. It all spins in the one direction. But if you look at it at the right, if you look at the north, it'll be spinning from right over your head from right to left. If you turn around and look towards the south, it'll be spinning over your head from left to right. So they're not spinning at in two different ways. So Bob, you were not being honest when you said that, as I know you know better than that. So I think although it was a very scrappy presentation, I think it completely disproves all the points that Bob put forward. Even though I didn't get a chance to look into the fibre optic gyro and the ring laser gyro, the analemma of the sun disproves Bob's assertion there. The gyro compasses the electric current with the mercury and the North Pole's magnetic current disproves the gyro compasses in the first place, because the original gyro compasses, that's how they worked, even though they asserted gravity and they asserted Earth's rotation. It had nothing to do with it. So I think, and the EQ mount, the sky proves the Earth to be flat, completely proves the Earth to be flat. All the stars in the sky proves the Earth to be flat. And the EQ mount proves it to not move. So all the things that the globe are saying for years prove the globe. EQ mount, stars in the sky, gyro compasses, ring laser gyro, and fibre optic gyro. Those 5 things, I'm sorry, they actually prove a stationary flat Earth. Okay, thank you for watching, and I know it was very long, and thanks for sitting through it, and I hope it was enjoyable. Bye.
Okie dokie, guys. Well, that was a long presentation, but very in depth, and it does look like there's an awful lot of work gone into this by the amount of files that you can just see there. So give me just a moment to try and get him back on Skype. Won't be a second, guys. Hello. Hello. How's it going?
You can hear me?
Yes, I can hear you. Excellent. Well, that was a bit of back and forth, especially in the chat as well. I mean, I saw the chat lighting up. It was on fire. Yeah.
I actually, if I could have done the whole presentation more concisely, it would have worked better. But it's still, the point still got people arguing, which is kind of what you want.
I mean, I suppose you can do that if you do a presentation for as long as you have, because you seriously went in depth there. Again, it all comes down to the scrutiny of the chat, and we actually have had a few questions in already. So if you just give me a second till I get to the very first question. So essentially it says, you made a positive claim that gyros have mercury in them. Have you opened one up to prove your claim, or are you assuming things?
No, that was from the newer gyros, the new Sperry gyros, gyro compasses. Is he talking about, this person talking about gyros or gyro compasses now?
That was just for gyros, I think. Let me just read back the question.
I'll answer it anyway.
Yeah, you've made a positive claim that gyros have mercury in them. So it wasn't specifically about gyro compasses, but just gyros in general. And then we also have along the same lines another question saying, where did you get your information about gyroscopes?
Yeah, where I got both that information, both of those questions are answered by the Sperry gyro compass handbook. That's where I got it. I was showing it on screen. It's the handbook of the older gyros, the original gyro compasses. As the gyro compasses they have now have fiber optic gyros in them, so they work different. They don't have the old mechanical in them anymore.
Okie dokie. Right, so we have a question from Toady. How do you explain the fact that the EQ mounts visibly move to adjust for the rotation of the Earth? You can look and see them tracking and altering the stepper motors on the ring mount.
No, there's a four-axis movement on the EQ mount. I'm not arguing that the EQ mount tracks the stars and all that. I'm not arguing that. What the point I'm making is that once you polar align the EQ mount to, let's just say in the northern hemisphere, you polar align it to Polaris, and once you polar align it, if you move that even an inch to the left or right, and you keep the exact same elevation, and you move it in the exact same line, it'll go out of alignment. So it's impossible for the EQ mount to polar align in any way to 3/4 of a degree off of Polaris or off of 3/4 of a degree off of Sigma Octantis. It's impossible for that to happen if the Earth is moving, because as soon as you would have it, as I used the 41 degree latitude in western Nebraska. I think it was 780 something miles an hour or something that the Earth supposedly rotates at that latitude. So that's going to, within an hour, you're 780 whatever miles away from where you started. So you can't stay polar aligned, because once it's polar aligned, it can't be moved at all. Otherwise, it will go out of alignment with any movement whatsoever. Yet we know that Polaris does move when we move. That's why it's been used by ships' captains for navigation for centuries.
What's interesting in the chat is that it's very divided between. You can see a clear divide between the Globers and the flat Earth people in the chat. People that I know and I know what side of the argument they're on. And essentially, you're getting a lot of kudos from the flat Earthers for what would essentially be a very good presentation. And you're getting an awful lot of hate from the Globe side, saying it was a pretty crap presentation, essentially. So it's very clear that there's still a way to go in this subject. So let's carry on with some of these questions. So
I agree.
From Bob the Science Guy, ask him what the right-hand rule is.
I don't know what the right-hand rule is.
Did you get into that? Was that question brought up in the chat prior to me asking you just now?
No, I didn't hear that.
Okay.
That's something else to do with gyros. I only worked on what the original gyro compasses did. The assertion in the handbook is that it's Earth's rotation and gravity. Yet the Mercury with an electric current running through it, which it does have, and the magnetic north proves why the Mercury tube is on the horizontal axis is turning clockwise. And that's, if you look at Vsauce did a video on a very basic video, I think it was Vsauce, on the basics of a gyro, and exactly what the Mercury is doing is exactly what's causing the torque, and the torque causes the precession. So that's, I didn't need to go any further on that. There's no point me. I would have to go down the road of learning about ring laser gyros, or fiber optic gyros, to go any further on that, because I just wanted to get down to the bare bones of it, because there's a lot in it, and to learn about it, even just to spot that much, as I proved with the Mercury, I can prove what I say with the video, the 3-minute Mercury video. whereas it's on the ball side now, or Bob's side, to prove that it's the rotation of the Earth and gravity. And even though his presentation wasn't on gravity, it's asserted that it's gravity involved in the gyrocompass, in the working of the gyrocompass. So now that's two assertions, rotation of the Earth and gravity, that have to be proven for his assertion to be true.
Okay, so a follow-up question from Toady. Can you present your data for observations around the claim the Earth is flat and a small sun revolves around and changes size and is close to the Earth? Can you share these observations?
Yeah, the analemma of the solar analemma, tend to look at the solar analemma, that explains everything. That's the data. The solar analemma is the data. As the solar analemma does not work on the globe, that's the very thing that the globe side had the biggest problem with, was to explain the solar analemma, and that's why you have the further away from the sun in the northern summer, and closer to the sun in the southern summer, and all that. That's and the slowing down when you're furthest away from the sun, and speeding up when you're closest to the sun. All that nonsense. That's all based around the solar analemma, because the globe needed to explain the solar analemma. For the person asking the question, for them, they should ask themselves, this is important. Everything that involves the Earth rotation involves watching the sun move around in the sky. So what is more likely? That the sun is moving around in the sky because that's what you see it do, or we are moving around because the very thing we don't have evidence for. So the data is the solar analemma. That is the data.
Okay, so we have a statement from Brenda von Assen. No. Kudos to him for his many proofs of the globe tonight. Okay.
Actually, look, Brenda's going to say that, actually.
So from Bob the Science Guy, that is how gyrocompass works by the right-hand rule. And from Toady, which is an actual question, you claim that the Earth doesn't move and the EQ cannot be polar aligned. You accept EQ mounts work, therefore how do you explain the fact that as they are created based on a globe moving?
Okay, I'll answer. First of all, I'll give a reply to what Bob said about the right-hand rule. I think the right-hand rule, this just going off of logic, is the fact that you set the compass, when you're setting the gyrocompass, the original mechanical ones, you set the mercury tube, which is the horizontal axis, you set that east of north. So that would be right hand to north. If you're looking directly, if north was directly ahead of you, in front of you, you would set that the mercury tube east of north, which would be the right hand of that. That could be what he's talking about. I'm not sure, but that would be logically what I would think of. Tody's question was, how does the EQ mount work if it's designed to work on the globe? Was that basically it? If you wouldn't mind reading me that question again.
Okay. Yeah.
I think it was how does it work? How does it work on a flat Earth if it was designed to work on a globe? That was basically it.
I'll read it to you again so that there's
okay,
there's nothing missed. Just bear with me.
Yeah.
You claim that the Earth doesn't move and the EQ cannot be polar aligned. You accept that the EQ mount works. Therefore, how do you explain that fact as they are created based on a globe moving?
Very simply, the person who created it pre-assumed that they were on a globe. That's why it's designed to be a polar line 3/4 of a degree off a Polaris. That's the reason. It's designed, that's why it's so complicated. It's like everything else in the globe model. It's very complicated. It's a fantastic, as an invention, the person who did it, their abilities, their intelligence was fantastic. But they just pre-assumed they were on a globe, as everyone else did. That's what it is. It's a pre-assumption of a globe. But the problem is that actually completely proves the Earth to be stationary. So it doesn't prove flat, right? The EQ mount is not proving flat because it's looking up at the sky, but it's proven stationary.
Okay, so from the Adam Meakin, the right-hand rule is a demo for people who struggle to understand the concept to help them visualize the field direction. That's what his answer is for that. So we have again another follow-up question from Toady. You make a major claim, so just saying analemma isn't enough. I am asking for your observations. There are multiple aspects that don't work on your model. not just the analemma?
Well, the analemma is the data. The analemma is the oldest data of the sun, and it can't be argued with. The analemma does not work on the globe model without a lot of crazy nonsense added in. It works absolutely perfect on the flat Earth model. And I don't know when Tony is saying there's so many things that don't work on your model. I don't have a model. I use the word model in the presentations just because it's easier for people to understand. And because I'm saying the globe Earth model, I'll say the flat Earth model. I don't have a model. This is where we live. We're what we're living on. As far as my observations, I don't have to make all those observations because people have already made them for me for hundreds, maybe thousands of years. And the analemma is the data. It works on the flat Earth perfectly, but it does not work on the globe without a lot of crazy nonsense added in. Right. So if he's looking for, if he might have to ask, maybe he wants to redefine the question or something. But if he wants better data than the analemma, there is no better data than the solar analemma. That is the data.
Okay, bear with me because I just had a question. I've just missed it. Oh no, so it wasn't a question. It was a statement from Sky's the Limit. EQ mounts do not take into account any of the so-called movements of the Earth. They simply track the stars in a circular movement, not an elliptical one. Would you agree?
Yes, that's true. Yeah, they're designed for tracking the stars. Not designed for the movement of the Earth. It's just pre-assumed that we're on a globe by the person who made it. Or maybe it wasn't pre-assumed. I'm just saying it was pre-assumed because that's what I'm saying. I'm thinking because of the fact that it's polar line 3/4 of a degree off of Polaris, which is speak about the true north being 3/4 of a degree off of Polaris. But I can't know what the person was thinking when they were making it. That's only just a logical deduction. But as I said, I'm not that person, so I don't know.
Okay, so from Brenda Van Assen again, apparently yourself has never actually shown that the analemma doesn't work on a globe.
I did a week ago there. I absolutely hammered it a week ago. There's no way for it to work. When I say it doesn't work, you can calculate it on the globe, but you can't physically make it work.
Yeah,
that's the problem. You can make it look... Sorry, Randy.
No, I just have to agree. I do remember last week you did present exactly what you're saying. So if you need to check that out, look up the solar analemma, whatever it's called, from last week, and you'll see it on there. It's at the start of the video too. So from the Adam Meakin question, was the analemma used to navigate before the Earth was assumed a globe?
Yeah, well, they definitely knew. I don't know if it was used for navigation. Adam might know a lot more in that direction than me, but it was known before anyone assumed the Earth to be a globe. The analemma is a very, very ancient symbol. They knew about the analemma a long time ago, as they made a point of what's the word I'm looking for? Made a point of recording where the sun was in the sky throughout the year. Whatever, I don't know how they went about it, but they knew about it a long time ago. So it very likely was used for navigation, as it could be used for navigation, where the sun is in the sky, the height of it, where it is in comparison to different continents and that. You could totally find out where you are or where you're supposed to be.
Okay, so Toadie's not impressed with your apparent lack of data and just with your explanation, so I'll read the question.
Okay.
Of course you need to present evidence. Hand-waving, no model, and no explanation for lunar eclipse, sunrise, sunset, solar eclipse, seasons, and I can go on. No data and no explanations.
No, it's like, for a start, there's somebody who just asserts things without knowing. The analemma completely explains all the seasons. Without a doubt, 100% explains them on the flat Earth. The seasons aren't a problem whatsoever. The eclipses thing is something I'm looking into. But has anyone taken the fact that the sun rises and falls and moves different speeds and gets a wider and a tighter circle throughout the year when they're thinking about eclipses? Like, I don't know what's making eclipses. I don't know what's doing that. I'm not up there. I don't know that. But I know one thing is that what Tony actually doesn't know either. He just assumes that it's a globe Earth. He actually doesn't know either, so he's assuming that it's the Earth that's getting in the way. But where's the evidence of that? where's the evidence that it's the Earth that's in the way of there's a round Earth in the way of the moon and the sun or whatever else, I mean, making assertions that we can't explain a solar or a lunar eclipse on the flat Earth. It's the same thing for the globe Earth. How did they explain that? How did they prove it? Where did they go to NASA? They don't have a good track record.
Okay, so Bob's made a suggestion, but perhaps not tonight. He'll be driving soon and he'd like to hop on for a second to set this guy straight. However, he goes on to then say that the sound quality will be bad. And if he's driving soon, I don't think it's really enough time to just come on and just have a quick back and forth. If you guys want to get into this and do a proper back and forth.
Not proper, yeah.
I mean, I can work with you guys. I could work on just 5 questions each or 10 questions each. As many questions as you feel is going to be enough to actually get your point across. And if that means more than 5, I'm quite happy to do that. It'll be a longer debate, obviously, but essentially we'll try and get down to the nuts and bolts, because it's very clear that you guys have a big difference of opinion here, and it's really split down the middle. So, would you be happy to do a debate with Bob at some point in the future?
Absolutely would. Bob coming in here now, what he's going to do is going to come in here and he's going to throw a couple of things at me and then disappear. And it's going to be stuff that he knows about that I probably don't know about, some inner workings of the fibre optic gyro or something like that. So I don't know what he's going to do, but just popping in for a second and going off, he's just going to come in. It's like come in, hit me in the back of the head and run off. It's that kind of a thing. So if he wants to debate, we'll do a proper debate, and we can do the 5 questions thing. He's trying to. Bob tried to give me an ultimatum in the chat that it has to be Tuesday at 6. It's either then or no time. This kind of stuff. It's like, I'm flexible. He said Tuesday at 6. I said Friday at 9. He said it's Tuesday at 6. And he didn't even say just because it was working. He did add in he was working, but he gave me an ultimatum on it. It was like, it better be then or else kind of attitude. And it's like, that's not the attitude. I have no problem debating Bob, but Bob has to show a little bit more respect and has to understand that not just him, he's not the only person with a life. So it may not be next week, it could be the week after, but I totally want to. That was why I came back with the presentation, was the intent of having a debate with Bob.
Okay, that's good. I'm happy to work around you guys. If you've got a set time, it could be later than normal, earlier than normal. I'll try and schedule something if I need to finish work earlier or whatever, or get up in the middle of the night, whichever. I'll do this because obviously
we won't ask you to do that.
Let's get some answers here. So, but yeah, like you say, don't try and, for you especially, don't do what I did. Don't put your life on hold and put yourself into this and take too much time of your life. Don't let it overtake your life. Anyway.
No, I understand.
Let's see. I'm just looking for some more questions. There doesn't seem to be an awful lot of questions right now. Apart from Bob saying that you're clueless.
Yeah, he's had to say that many times. He has to prove it though. That's the problem.
Alright, so where's the video of yours that you just spoke of? So I think it's round table 11 or round table 12. It will be solar analemma proves the flat Earth. So if you just check my channel out and click on my videos, it'll probably be about the 5th or the 6th one that was done last week.
It was last Friday at 9. I think it was number 12. Number 12. It was on the 19th. It was on the 19th. Number 12 on the 19th. I just saw in the chat there, Bob said, I haven't learned the debate, so do more research. And he said goodbye to you or something like that. So it's up to Bob.
To be fair, you have poked the bear. Essentially, your entire video was basically an hour and a half of poking the bear with Bob. So it's going to be from Bob's position. He's sitting in the chat, so it is kind of one of them that he's in the chat. You're doing a presentation, and you must have mentioned his name 80 times, maybe something like that.
Yeah, I did. Well, it was. But it was. That was the point. The point was to be a rebuttal to Bob. It wasn't a personal thing with Bob, but it was just that it was going to be a rebuttal to what he put out. And there's no point in me not mentioning his name. Isn't that it? I mean, he made the presentation. I'm giving a rebuttal to that presentation, so I have to mention his name.
Yeah.
I mean, what I said about the Mercury, did Bob ever even think of that? You know, that's the thing about it. Like things like that. It's like Bob. There's no point in Bob saying that that's nonsense. He hasn't proven it to be nonsense. You know, things like that. But
okay, and the reason I like the structured idea of a debate is because it gives both sides time to prepare a response. And if you're not prepared, if you don't understand the question, or you have limited knowledge in that actual part of the question, you can go and research it. You know, and it gives you time to actually do that, so you can actually get into a proper debate rather than, like you say, running in, hitting you on the back of the head and running off. You know, I don't want that here really. I would rather like a structured questions up front. People know what's going to come their way. They can prepare for that, and that's the best way I think that we're going to get proper answers. You know, so. Yeah, I'm happy to work with that. So Bob in the chat, if you want to email me, obviously, or speak to me on Skype. I know you've messaged me on Skype. We'll try and work a day out, try and work a time out, and I'm happy to do something, work around you guys. So I'm looking.
Bob
for
said
questions,
he's not working. Sorry,
I'm looking for questions.
Sorry,
It doesn't seem to be any questions right now.
No.
Yeah, there really doesn't seem to be any more questions. So, in that case, I guess I'm going to have to wrap this one up. Is there anything you actually want to say before I go?
Yeah, a couple of small bits. Three things. One, I said in the presentation that if you set, I have to say this because it was only after I recorded it, I remembered it was wrong. If you set the Mercury horizontal to the opposite side, which would be west of north, that it will go the other way. It won't, because of the type of magnetism that's coming from the North Pole. It will always turn clockwise, not anti-clockwise, because of that. I don't. That is something that whatever. I'll have to ask the guy in the video who made the video which direction, which magnetism it was a positive or negative, because it turns clockwise with one and anti-clockwise with the other. So I want to find out that, and that'll tell us what the North Pole is, as in what magnetism it is. Or at least give us a good indication. So I just wanted to put that straight. Secondly, Bob and me having a debate. If Bob tells you what days he's free, what evenings he's free in our time, I'll do what I can. I may not be able to do it at 6. It might be a bit later in the evening. And if I can't do it on the Tuesday, as Bob says, we'll try and work it a different day. I'm flexible. I'm open, but I can't be there Tuesday at 6. It would have to be later in the day on Tuesday for me to be there, like 8 o'clock, something like that for me to do it, 7:30, 8 o'clock for me to do it. And the third thing is, Rumpus last night said a lot of very unintelligent things concerning after watching 15 minutes of my Analema presentation, and he called me a moron or an idiot or something many times. Well, my challenge is out there to Rumpus. If you want to make a presentation against my one and then debate me afterwards on Ranty Show, I'm quite happy to do that, and we'll see if I'm an idiot or if you're an idiot, because I know from what you said that you are totally wrong, Rumpus. Thanks, Ranty, and thanks to everyone who watched and was part of the show tonight.
No problems, and thanks for your effort that you've put in. Again, you've put an awful lot of effort in. I mean, how long have you been collecting these slides and stuff that you've been showing through today?
Well, actually, that was literally in the past week. I got hundreds, and what actually happened to me is part of the reason why the whole thing was scrappy and took longer is there was a load of images and diagrams I had ready and made that just disappeared on me for some reason. I don't know where they went, but they disappeared. I had really good images of the sky, showing a huge amount of the sky from the equator, and showing basically both spirals in the sky, the one over the center and the one moving on the outside. And I had really good images of that, and a load of other stuff and diagrams I made, and they just all went missing. So literally what happened to me is I sent you an email on Sunday saying I wanted to do a rebuttal to Bob's presentation, and then what happened is it got to a point where I probably needed another week to do it really proper and do it really well. But it doesn't matter. I didn't want to not have a presentation for you for tonight. So I had to just gather up as much stuff as I could and make of it what I could in the moment. And so all these images and stuff, they're literally crowding up my computer. Everywhere I go, I have folders of images everywhere of the sky and of the Annalena and all this other stuff. So I don't know where. That's why I couldn't find maybe the things I was looking for, because they had gone missing in some folder somewhere, and I couldn't find them.
Well, as I say, thanks very much for what you've done. You managed to stick to your word and get the presentation done for Friday, which was excellent, really. And it seems like, as I say,
Thank you.
The one thing I would say is that because the chat has been so quiet, and it seems that there's just the one typical question about Mercury that's cropped up a couple of times. Essentially, barring that, it doesn't seem that there's that many rebuttals immediately. Maybe I've missed quite a few things, but either you've talked them to death,
that's possible,
or they don't actually have anything. But either way, I do appreciate the effort that you've put in again. So thanks for stopping by.
One last thing on the part of the presentation. Well, the part where I was showing the sky, where I was showing all the sky, and that time-lapse virtual reality movie of the sky from the equator, showing the whole sky. That is a very, very good proof of flat Earth, as you cannot see all that sky on a globe. You just can't do that, right? To see the two poles, the sky poles on a globe, you can only turn one way and look down to see one, and then turn around and look down to see the other, if you were lucky. And I don't even think that would be possible on a globe. You wouldn't be able to get up high enough to be able to see down. So there wasn't much about that. I thought to be more, but then again, it was a very long presentation, and I suppose people are going to go with what they last heard.
Okay.
Okay.
Well,
Thank you.
Thanks very much. I'll give you a call back in around about 10 minutes. I'll just round up the show.
Yeah, no hassles. On the board. Thanks. Talk to you in a while.
Bye-bye.
Bye. See you, everyone. Thank you.
Okay, right. Well, guys, thanks very much. Again, it's been a really long presentation. I hope that you actually got something out of that. I hope you enjoyed it. I certainly enjoyed it. I would love to see a debate happen between Bob and Brian. I would love that to happen at some point. In the meantime, on Monday, we've got Paul on the Plane. Quite a well-known flat earther. You guys will know him. Very into his NASA, and NASA is fake, and the moon landings were faked. And he will be doing a presentation, 10 p.m. BST, London on Monday, London time, Monday, on this channel. So stay tuned. Essentially, we could hope maybe at some point have a debate even between Gem Panda and Paul on the Plane. Now that would be something really cool, because as far as flat Earth and globe Earth go, I mean, these guys are right up there for the best, especially with the moon landing stuff. So to get these two to perhaps have a potential head-to-head is something to look forward to for sure. We have Iron Realm Media starting in 10 minutes. That's Iron Realm Media, and their show will be starting in 10 minutes. If everybody wants to carry on and have more Flat Earth tonight, then that's the place to head over to. I was going to check the super chats, but there's nothing to respond to. There's no super chats today. So we've had two shows. We've had an hour and a half and almost 2.5 hour show on this particular one. So I hope I've entertained you for the last 4 hours. It's been a long night. It's been a long week. And yeah, looking forward to the weekend. And I guess I'm going to see you guys on Monday now. I think I'm going to have the weekend off. Anyway, thanks for stopping by, guys, and I'll see you all in the next one.